Good morning, students. Today I am going to talk about electronic configuration. And before I start with electronic configuration, I think we should all know a little bit about the quantum numbers, because the quantum numbers are very important to place the electrons in their desired positions. So let's just have a look to the four quantum numbers. So there are four types of quantum number. One is principal quantum number denoted by n, which indicates the shell, that is K, L, M, or n is equal to 1, 2, 3. And azimuthal quantum number indicated by L, which indicates about the number of subshells. Like for example, K shell is having only one subshell, that is S, and M is the magnetic quantum number, which indicates the subshells, or you can call it as a orbitals. For example, if you are talking about principal quantum number N, so it has two subshells, that is S and P, and both in all they will have 1 plus 3 orbitals, right? And S is the spin quantum number, which indicates the number of electrons. So let's begin. See, this is the modern periodic table, and the whole periodic table is divided into some vertical column, that is 18 vertical column, and 7 horizontal column, and these horizontal columns are called as periods, and the vertical columns are called as a group. Alright, so what I have done is I have just take a blank periodic table, and in which I have just mentioned the general electronic configuration. And electronic configuration is the systematic representation of electrons arrangement in different shells and different orbitals, which gives us all the information about that atom and the electrons and their energies. Right, so this is the whole periodic table, which is a blank, and the elements in this periodic table are divided into different blocks. For example, this is called as S block element. Here you can see the S block element, because the electron are going the last electrons are going in S orbitals, right? And here you can see the P block elements, again same, because the electrons are going in the P orbitals. And in the middle you can call them transition element or D block element, and inner transition or F block elements, right? The general electronic configuration is NS1 or NS2 for S block element. For P block element it is NS2 NP1 to 6, right? And for D block element it is N-1 D1 to 10 NS1 to 2, right? So this is the general electronic configuration. And here I have already mentioned 5 elements in this periodic table, like copper with 24, manganese 25, nickel, chromium, manganese, nickel, copper, and zinc, because they are having a different electronic configuration. Unusual, you can call it as an unusual, because of the change in energy or difference in energy level, so that the electron move, or electron does not gone into a general or desired place, but there is something some change in this distribution of electron. So this is the general electronic configuration. And what is important to know or remember while distributing the electron, that there are 3 rules. Right, so there are 3 rules. One is Ohm's rule. Pairing of electron not take place until each orbital of same energy is filled. Pauli's exclusion principle. No two electrons in an atom have same set of 4 quantum number, and Bohr principle, that is electron feed in order of increasing energy. And one more thing that is very important, that is Bohr-Bury rule. Bohr-Bury rule can help us to decide which orbital is having low energy and which one is having higher energy, and electron always go in the lower energy orbital. Like for in this example, the total orbital with lower n plus L value will possess lower energy. For example, if we are talking about 4s and 3d orbital, and somebody, or if you want to fill the electron, then where in out of these two orbital electron will be entered. So the Bohr-Bury rule says n plus L. N is the principal quantum number and L is the azimuthal quantum number. N is the principal quantum number in case of this 4s orbital. 4 would be the n, so here it is written as 4, and S is the azimuthal quantum. S is the orbital or subshell which is indicated by azimuthal quantum number, that is L, and L for S is 0, that is 4 plus 0 is equal to 4. And in case of 3d orbital, N is 3 and D means if L is equal to 0, then S orbital, S is equal to 1, then this is P orbital, and if L is equal to 2, it will represent the D orbital, and here it is D, so 3D is 2, 3 plus 2 is equal to 5. It means for 4s orbital n plus L value is 4, and for 3d orbital n plus L value is 5. It means definitely the electron will be going to 4s orbital, not to 3d, because the energy of 4s orbital is lower. So this is very important while filling the or feeding the electrons into the orbitals. In case of Bohr-Bury rule, when the value of n plus L is same for different orbitals, for example here it is 3p orbital and here it is 4s orbital, and the n plus L value is 4 in both the cases. In such situations, the orbital is considered as lower energy whose principal quantum number is lower, or you can say the value of n is lower for 3p orbital because the principal quantum number n is lower for 3p orbital, not for 4s orbital, so the electron will enter into the 3p orbital. That's it. So these are the two situations which should be considered during filling the electrons in according to Bohr-Bury rule, or deciding the electronic configuration of any atom. Right.